Algebra 1s, and welcome to the Chapter 1, Lesson 2 notes video. So here we go, right? Last time we were talking, we talked about real numbers, and we talked about how the set of all real numbers is made up of rational numbers and irrational numbers, okay? Well, it turns out in order to be a real number, you have certain properties that you are able to do. And we are going to talk about those certain properties today. Now, there's 10 of them. So I'm just going to list those 10. I'm going to say their names. So you hear me say their names. And then I'm going to go through each one distinctly with both a general example using letters and then a numeric example. And that's using a real life whole number scenario that you can wrap your head around. Now, all of these things I talk about today, you actually know that they are true. You just don't know what they're called yet. Okay. So there's 10 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Always reassuring when you find out your math teacher can count. Huh? Okay. So here we are. We're going to start with the commutative property of addition and the commutative property of multiplication. So there are two commutative properties, one of addition, one of multiplication. They do say the same thing, which what they say is you can switch the order that you're adding two numbers in, and you will get the same result. You can switch the order that you're multiplying two things together in, and you will get the same result. That's what the commutative property is telling you. So a general example looks like this. A plus B equals B plus A. That is what the general form of the commutative property looks like. Here, let me zoom in a little bit more. My wheel is stuck, I'm sorry. There we go. You can still see the whole chart, right? A numeric example would be if you take 3 and you add 4 to it. What do you get? If you said 7, great job. And that will be the same answer that you would get if you added 4 plus 3. If you said 7 again, hey, good for you, right? Because that's the answer either direction that you add that switch of order, okay? It's the same thing with multiplication. Now remember, let me say another thing before I go too far. I'm writing things down, you're writing things down. So even though I'm not physically in front of you and you are not physically in front of me, as you're watching this video, you are writing down what I'm doing, okay? Awesome. See, I knew you were listening. Now, notice that'll be the same with multiplication. And in algebra, we use a multiplication symbol as a dot or parentheses around something, okay? So I'm going to use a dot today. A times B equals B times A. Okay, that's our multiplication symbol. By the way, when you have two letters and there isn't a symbol between them, it's assumed that you're multiplying. Just a heads up. I know you don't normally see this, and in chapter 6, we'll learn why. Okay, but this is telling me that it doesn't matter if I multiply A first and then B, or B first and then A, I'm going to get the same answer. Okay, let's do a real life example. Let's use 3 and 4 again. 3 times 4 is 12, and 4 times 3 is 12. And there you have it. So now you have another in your face, yeah, I knew that. It's one of those where you're kind of like, oh, now once I hear it, yeah, I always knew that was true. I just didn't know it was called the commutative property. Notice of addition and of multiplication just means which operation am I using at the time. But the commutative property as a general property is switching order. Can you see what I'm writing at the side? Good, okay. All right, that's the commutative property in general. It's switching order. Moving forward, the associative property. So the associative property is three things are either being added together or multiplied together. And it doesn't matter what you group together to do first. So when you add or multiply three things together, obviously you do one part of the operation first and then add or multiply that last thing. So we're saying whatever the grouping is that goes first doesn't matter. You're going to get the same result, whatever the order is that you're multiplying all those together in. It's almost like a combo with the commutative property, right? But we call this the grouping property because now there's three things involved, three letters involved. So the associative property of addition, the general example, is going to be, I'm way out of your way. Hold on. My cords are all over, so I don't want to get things too messy over here. A plus B in parentheses, then plus C. So A plus B would go first, then you add C. Will actually give me the exact same result as if I put A plus and then B plus C in parentheses. So they would actually be added together first. It's kind of confusing until you think of a real life number example. And so my real life number example is I'm going to do 3 plus 4 in parentheses and then add 5. Okay, let's see what we get. 3 plus 4 is 7. You remember that from up here. And 7 plus 5 is 12. Okay, so I got 12 on this side. Now let's test that theory. Hypothesis. Theory is when it's been proven. Sorry, I used that wrong. Tell your science teacher I corrected myself. 3 plus 4 plus 5, right? So now we're saying we have to add 4 plus 5 first. So 4 plus 5 is 9. 9 plus 3 is 12. I got the same result again. I got 12 again. It didn't matter which group I added together first, but all of them have to be adding, or all of them have to be multiplying together. So it's one property or the other at a time when it comes to the associative property. So this one looks like A, B in parentheses times C equals A times BC. Okay, so the groupings, right? And notice this time I didn't use dots. I'm just telling you that I'm showing you, I'm indicating to you that when two letters are next to each other, multiplication is assumed. Okay, so multiplication is what's going on here. Real life scenario. I've been picking on the same numbers. Well, you know what? No, you guys can multiply good numbers. So let's do 3 times 4 and then times 5. See what we get. 3 times 4 is 12. 12 times 5 is 60. 12 nickels, right? Think of it that way. Money. You guys always can figure out money. So I got 60 by this multiplication. Let's try it the other way where we leave 3 out first, and then we're multiplying 4 times 5 together first, right? So 4 times 5 is 20. 20 times 3, 60. And there you have it. Didn't matter which group we did first. It worked. What if I grouped 3 times 5 together first? I get 15. And now I multiply by 4, I get 60. So even that potential third way, right? That potential third way. That third way would be this. It's changing an order. So it's also commutative property because I changed my order around. But if I group these guys together and then this guy gets multiplied after, then that's still the same result. Commutative and associative over there. Cool stuff. So notice the associative property is the group change. The associative property is a grouping change. And the distributive property, notice it's not of addition or of multiplication. It actually deals with both. So we knew at some point we were going to have them both talked about at the same time, and here we are. With the distributive property, and I know you've worked on this prior to now, but with the distributive property, you've got whatever's being added in parentheses, and then whatever's being multiplied is the thing outside of the parentheses. So the general form is A times B plus C is actually equal to A times B plus A times C. So a lot of times what we do with this is we do that little like rainbow look, right? We're distributing or giving the A to both the B and the C by multiplication. This is going to be really helpful when we start solving equations later on. Okay, so this is going to be really helpful to us in the future. So the distributive property says that I can multiply A times B, and I can multiply A times C and then add their results, and I get the same answer as had I added these first and then multiplied. So let's test that out. Again, we'll keep using 3, and then 4 plus 5 is in parentheses, right? So let's see what we get. 4 plus 5 is 9, and 9 times 3 is 27. So by doing this order, I got 27. Let's try doing this order. 3 times 4 plus 3 times 5. Sorry, sometimes I write my 3s that way. 3 times 4 is 12. 3 times 5 is 15. 12 plus 15, 27. There we are. Got it either way. So the distributive property is both things. Okay, the distributive is giving by multiplication. You've given both things in the parentheses by multiplication. Notice now I go back to having kind of pairs, right? So the additive identity and the multiplicative identity really talk about the same thing, but use a different operation to talk about it. So there's this cool thing that happens in adding that if you take any number and add 0 to it, you get to keep that number's identity. So if I take A and I add 0 to it, I still got A. I've not changed its identity. That's the identity properties here. Okay, I'm not changing these identities. So if you take 3 and add 0, what's your result? 3. You didn't change its identity. Multiplication has one of those, but multiplications is 1. So A times 1 is still A. A times 1 is still A. Okay, so notice there's just a different number that we can do that with, but that still happens. So think of it this way. 3 times 1 is 3. Its identity didn't change. Okay, its identity didn't change. Inverses are different. They do kind of reference this identity issue, but they're not the same. So I know they both start with I, so they can get a little confusing. Inverses are opposites or reciprocals. And I know you've heard both of those words before, but now we're going to get more specific about how we use them. So additive inverses are also known as opposites. And opposites are the whole number and its opposite sign, right? So the whole number, and that's negative. That would be like having 3 plus negative 3. What does that equal? 0. Opposites or additive inverses add up to nothing, add up to 0. Oh, did that in the wrong box. Sorry. I'll put the A over here. A plus negative A is 0. Sorry about that. That's my bad. Right? You have a number, a whole number, so it had to have been positive, right? 0 and all the positives, right? And then add its negative to it, and they cancel each other out. They even each other out. And I know you've heard the cancel each other out thing, and I'm going to use that when I talk about solving equations, but that's what's going on. This is why I need to talk about additive inverses here and today first, so I can use those tomorrow when I'm solving equations. All right? Now, multiplicative inverses are different, okay? Because multiplicative inverses are reciprocals. Spell that correctly. Reciprocals, right? Reciprocals are a number and its flip of a fraction, okay? A times 1 over a. I just flipped that fraction upside down. That is a reciprocal. And those actually multiply together to give me 1 again. So they multiply back together to give me 1. Okay? Let's give you an example, and I'll use 3 again. 3 times 1/3. Now, when you multiply a whole number times a fraction, the whole number times the top, so 3 times 1 is 3. And you kind of imagine that there's a 1 under this 3. So 1 times 3 is 3 for this bottom. Hey, what's 3 divided by 3? It's 1. Reciprocals will multiply together to give me 1. That's the other way that you can think of canceling each other out. That should look familiar. And that's what we'll be using to help us solve equations too. That's why we need these inverses. We need to think of them separately, right? So this is how we do the canceling. That's how we do the canceling out. And the zero property is exactly as easy as you think it is. What's anything times 0? It's 0. It's exactly as easy as you think, right? 3 times 0 is 0. Anything times 0 is 0. That's why that poor little zero property is off on his own there, right? Okay, great place to stop. Make sure you've got these filled in. Pause it. I'm probably going to throw a question in here, right? And then we'll move forward, okay? We'll look at some examples together. Did you stop? Did you pause? Did you assess? Good job for you. The additive identity. I bet you have a guess for this one, and an educated guess. 0. The additive identity is 0 because anything plus 0 is itself. It stays its identity, excuse me, right there. Anything plus 0 stays itself. The multiplicative identity, now you have a really good educated guess, is 1. Anything times 1 stays itself. It keeps its identity. All right. The additive inverse number is that number with its opposite sign. Sorry, I started writing an S and really didn't finish it. It's opposite sign. And then the multiplicative inverse is the reciprocal. And I know I said those already, but it really is vital that you know those vocabulary words. The language that I use this year will be that next level up from where you started in the pre-algebra. So you've got to know when I say opposite, I mean the opposite sign of the number we already have. You've got to know when I say reciprocal, I mean take that whole number and flip it upside down in a fraction. Okay, these are things that's what we're moving forward with this stuff. Okay. Continuing. What we're going to do here is we're just going to go through, and you can, this is a really great spot to keep this, your table, kind of near you, right, while you do this. So that's part of why I do the notes all in one thing. Okay. We're going to, I'll pull this back each time so I can see how to spell it, see my examples, what am I looking at, right? So we're going to say which property and type is illustrated by each equation. The property is the name, like commutative, associative, distributive. The type is of multiplication, of addition. So that's why the line is so long. I want you to use the whole name on these lines. Okay? Here we go. M plus n plus p equals m plus n plus p. Our group has changed from one side of the equal sign to the other. So since my group changed, but not my order, see how my order stayed the same? My group changed. This is the associative property. Let's look at the sign we're using. It's addition. Okay, so associative property of addition. Now see how I wrote that whole thing out on the line? That's what you're doing right now. Okay, you're doing that, you're practicing that. I know it sounds a little funky, but it's so true that if you practice writing something out, that helps to embed it in your brain. How to, not just how to spell it, but also where it's used. Okay, it really does help out. So please make sure you're doing that with me as you're going. All right, next. I got parentheses again, so I feel like I'm on the lookout for associative property. However, then look at the other side, right? So now on the other side, I don't have parentheses. Okay, wait. Wait, in here it's plus, and out here it's multiplying. So which of my properties covered both? The distributive property. Okay, so that's how I kind of know things like this. So the distributive property is the one that's not of anything. Okay. All right, next, let's take a peek at our order. M plus N equals N plus M. I gave that keyword order, right? Switching order is the commutative property. What sign? Positive. Okay. Positive, I'm sorry, addition, right? It's the addition sign, the plus sign. M plus 0, right, equals M. So I'm actually adding, but not changing an identity. Identity. M's identity didn't change, right? So this is the identity property of addition. Okay. Oh, look, I'm multiplying two things together. One of them's in fraction form, one of them's in whole number form, and the answer is 1. This multiplying, right? So this is the multiplicative inverse. Okay, that's the multiplicative inverse. Anything times 0 is 0. Easy. 0 property. I bet you saw it. Order change. I'm sure some of you are now getting ahead of me at this point, right? Order change. So Mn equals Nm. I'm multiplying them together and I switch their order, switch order, right? Commutative property. So commutative property of multiplication. So I'm writing bigger than I normally do so that you can see it even better than normal. Order is the same, but grouping is different. Group change, associative property. What operation am I using? Multiplication. So associative property. Sorry, I lost what letter I was writing at that point. That happens when you get old. Associative property of multiplication. Okay. M times 1 is still M. Its identity didn't change. It's the identity property. I multiplied. So the identity property of multiplication or the multiplicative identity, either of those. That's what I wrote earlier. That works. I guess I just wanted to write the word property of. Okay. Last but certainly not least in this column, number 1, right? What are we looking at? Oh, different signs of the same whole number, right? So it's the whole number and it's negative are adding up to 0. That would be the additive. inverse. They are inverses of each other, right? They're opposites in that place, in that sense. Okay. Some multiple choices. All right. Which of the following is an example of an identity property? Oh, so it doesn't specify adding or multiplying, but I'm looking for an identity. So I'm looking for a place where the identity of the value didn't change. And I am seeing it right away. I'll give you a second. I hope you see it right away too. Wait time is funnier when you're alone to give someone a chance, right? So identity didn't change. Choice A. Whenever we have multiple choices, we write the answer on the line provided. Which of the following is an example of the community property? Oh, so again, they didn't tell me it had to be of addition or of multiplication, but I'm just looking for where did my order switch? And so I'm looking, order switch, right? So commutative property, order switch, choice B. Which of the following is an example of the associative property? Again, not telling me it needed to be of addition or of multiplication. So I'm not looking for operation. I'm looking for associative property, a group change, the group change. Now be careful. And I'm saying be careful because I know that there's a trick on this one. I'm going to give you some time. Look closely for a group change, not an order change. Did you find it? Look, this is trying to mess you up. This, the group didn't change. The group is still BC being multiplied together. This is actually the commutative property. Okay, so be careful. The group actually being changed, that's the associative property. So it's actually choice D. Be very careful about that. Okay. One more thing I want you to think about. Why are all of my properties talking about addition and multiplication? Why have none of my properties said when you subtract and switch the order, you get the same answer? Or when you divide and you do it in two different groups, you get the same answer? And that's because they don't work that way. I bet you heard it and thought of it when I said when you subtract and change the order, you get the same answer, right? You can just think of 5 minus 1. And what do you get? You get 4. So now change that order. 1 minus 5 is not 4. That's negative 4. And those are completely different values. And so because of that, as a result of that, we can't say that our subtraction and our division will give us the exact same results on both sides of the equal sign. So those are not properties of the commutative property of the associative property. Those don't work for subtraction and division. Okay, they only work for addition and multiplication. That's how these things work. Okay, so I just wanted you to kind of think about that a little bit, right? All right, I think we're good. Why don't you try that homework that's associated with it? It's very similar to these problems that we just did together. So please use this. Please use your chart. And from this point forward, I go forward assuming you know what I'm talking about when I'm saying the commutative property, when I'm saying the additive identity, when I'm saying the multiplicative inverse. When I say those things moving forward, I assume you know what I mean. Okay? Okay. Cool. Well, we're going to use these in a couple of minutes when we do the next video. So, guys, good luck with that homework. Email me or remind me if you have any issues, and I will be seeing you again soon. Oh, there's my mouse. Bye, guys.